Hi, my name is Maria Jose Romaris. I'm Tier 1 and I prepared this video to give a brief introduction to the different type of data that we can have in our studies. So we are beginning this statistical journey and I will try to keep it simple. Let's say that this week you can take this as a general introduction. Okay, so to begin with, I would like to differentiate descriptive statistics from inferential statistics. The first one is used to describe the data you obtain from your sample. You made your study, you collected your data, and then you desire to summarize all the things that you found. So for that, you will make use of descriptive statistics. But once you want to make an inference from your sample to the target population, you will need to use inferential statistics, and that will be the topic of the following classes. So that said, I would like to start by defining what a variable is. We have been talking about variables almost since the beginning of the course, but how can we define what is a variable? What do we understand for variables? In statistics, a variable is a characteristic of interest that you can measure, you will record, and you can analyze. Depending on the type of information they record and the role they have in the study, we will be able to define or categorize them. Now that we know what a variable is, let's talk about what types of variables or data we can have in our studies. So in this slide, you can see in this chart that we can basically categorize the variables into three types. Categorical variables, they can be subdivided into dichotomous or non-dichotomous variables. Then we have ordinal variables, and finally we have numerical ones. So let's start with the nominal data or categorical data. It's the same, we can call it nominal variables or categorical variables. And inside this category, we can find dichotomous ones that are those that can only admit two categories or two levels, and non-dichotomous ones, those that admit more than two levels. Nominal data is the simplest type of data we can have in our study. And nominal variables are labeled or named data, which can be divided into various groups that do not overlap. All the data that can be categorized and do not follow an order can be categorized as nominal data. Examples of this type of data is sex, blood type, race, marital status, for example. So let's think about the variable sex. When you record the sex of your study sample, the data you collect will end in one of two categories. Patients could either be female or males. Once you have your data set, you can codify this variable. For example, you can say that you will use 0 to codify for males and 1 to codify for females. But in this case, the numbers you are using will just act as labels, but they won't have an arithmetical or mathematical meaning. What we need to remember about nominal variables is that it is not possible to order the categories and there is no measure of distance between the values. And again, it is not possible to perform arithmetic or logical calculations with nominal data. So here in this slide, we can see part of a table 1 from one study, where we have two groups, placebo and intervention, and we can see one of the variables that the researchers recorded. In this case, we have sex, which is a categorical variable, and inside categorical, we can say that it is dichotomous because it can only take two values. You can either be female or male. And something important is that when you have nominal categories, they are mutually exclusive. So one person can logically be assigned only to one of the categories. In this case, for example, we had the 61 patients that were inside the placebo groups, and they were 28 were females and 33 were males. When we have nominal data, we can calculate the frequency of the patients in each category. So we can read absolute frequencies and relative frequencies. As in this case, for example, inside the female category, the absolute frequency is 28 and 46 between brackets is the relative frequency for the females in the placebo group. Then we have ordinal data, which is another type of data where you will have also categories, but in this case, there is a meaningful order among those categories. So, for example, let's take the visual analog scale for pain here at the bottom of the slide, where you can have zero pain, or you can have the worst pain you have ever had, which could be represented by the number 10. So as I mentioned, here we do have an order, but however, the magnitudes in this scale are just representative labels that shows us an order, but the intervals may not be consistent and may not even be known. What I mean is that the difference or distance between a pain of 4 and a pain of 5 may not be the same as the difference between a pain of 7 and a pain of 8. Moreover, we cannot say, for example, that 8 represents double pain than 4. And it could be that the amount of pain that 8 represents in one patient is not the same as the amount of pain that 8 represents in another patient. However, what we could always see or assess is that for each subject, 8 will always represent more pain than 4. So here the important concept again is that in ordinal variables, the value does not represent quantity, but only a relative position within a distribution. Finally, we have numerical data or numerical variables. In this case, values do represent measurable quantities. Inside numerical variables, we can have discrete variables or continuous. Discrete variables are those that only admit whole numbers, such as, for example, days at hospital, cardiac frequency, number of deaths. And the importance here is that there exists an order among the possible values, and the difference between values has a measurable quantity. And I can say, for example, if we take the example of days at hospital, that the difference between 1 day and 2 days is the same as the difference that exists between 3 days and 4 days, for example. Arithmetic rules can be applied to discrete data. And while discrete data have no decimal places, once arithmetic operations are performed, for example, if you perform a ratio or an average, then the result might not necessarily be discrete anymore. Then we have continuous variables that are also inside numerical data or numerical variables. They also represent measurable quantities, but here data is not restricted to whole values. Instead, they can take any value. Fractional and decimals are also included. The magnitude is important. An order exists among the possible values, and the interval between the values is known and is always the same. So here, until now, it is very similar to discrete variables. The only difference is that in discrete variables, the values are whole numbers, and there is like a jump between one value and the other with nothing in between. But when you have continuous variables, you will always have infinite values among one and the following, and you can have fractions and decimals. So this is the main difference. And for example, variables that are continuous are weight, stature, blood pressure, and In this case, for example, let's take weight. You can see that the difference between 15 kilograms and 16 is the same as the one that exists between 45 and 46 kilograms. Here, the grade of precision will depend on the measurement instrument that you have. For example, for weight, we can have a weighting scale that detects the person's weight until 10 grams increments, or a scale that detects only until 100 gram increments. Another important thing is that inside continuous variables, we need to differentiate between interval scales and ratio scales. And when we talk about interval scales, the main concept here that you need to remember is that in interval scales, there is no real zero. The 0 point has been artificially designated. But on the contrary, when you have a ratio scale, there is a real 0 point that has a real meaning. Let's see this with an example. So let's take the example of temperature. In this slide, we will first focus on this graph, the one that is above, where you can see the Celsius scale, and under that the Fahrenheit scale. Both are interval scales. Why? Because the 0 has no real meaning. 0 in the Celsius or Fahrenheit scale does not mean absence of heat, but they have the 0 point was arbitrarily designated. For example, in the Celsius scale, 0 is the point at which water freezes, and 0 Celsius degrees corresponds to 32 Fahrenheit degrees in the Fahrenheit scale. So when we talk about interval scales, we need to know that there is a measurable quantity, and for example, the magnitude here is important. The difference between 20 and 10 Celsius degrees is the same as the difference that exists between 10 and 0 Celsius degrees. And another thing that we could tell, for example, is that the difference between 60 and 30 Celsius degrees is the same as the one that corresponds between 140 and 86 Fahrenheit degrees. So we can make sums and subtractions when we have interval scales, but what we cannot calculate are ratios. For example, something that is incorrect or that is not possible to tell is that 60 Celsius degrees is twice as heat as 30 Celsius degrees. That's not true, because even when 60 is twice the numerical value of 30, it does not represent double heat in the physical definition of heat. Also, if you tell here in the scale there is the one of the Fahrenheit degrees, you will see that 140 Fahrenheit degrees is not the double or the exact double value of 86 Fahrenheit degrees, which is the corresponding values for 60 and 30 Celsius degrees respectively. So if you are really interested in calculating and knowing which is the exact double heat, double temperature of heat of 30 Celsius degrees, you need to record to a ratio scale. So if you go here to this figure, you will see at the very bottom that we have the Kelvin scale. This is a ratio scale because here the 0 is not arbitrary. The 0 has a real meaning, and 0 Kelvin represents absence of temperature. So if you really want to know how much is a double heat of Celsius degrees, you need to first turn 30 Celsius degrees into the Kelvin scale, which is around 303 Kelvin. Then you multiply that by 2, which is 606 Kelvin. And then you need to change that or convert that again into Celsius scale, which turns to be 333 Celsius degrees. So you can see that 60 was not double heat of 30 Celsius degrees. This is why if you study chemistry or you want to use a temperature in any equation, you will have to use Kelvin as a measure of temperature instead of interval scales. Kelvin is a ratio variable. If we again come to the slide where you have this chart, we can summarize the type of data into categorical. And to remember, we had dichotomous and non-dichotomous variables. Another type of variables are the ordinal ones. And finally, we had the numerical variables, which could be divided into discrete data or continuous data. And continuous data could be divided into interval and ratio variables or scales. And in this slide, we can see the levels of measurements that we can have. Here we have the ratio scale, which is the more complex type of data and the more complete one. There exists a meaningful order, there is a measurable difference between the values, and there exists an absolute zero. When you go to the interval scale, there exists a meaningful order. There is also a measurable difference between the values, but the zero is arbitrary. So while in ratio scale you can perform any arithmetical calculation, in interval scales not all of them can be performed. So remember that, for example, ratios cannot be performed when you have interval scales. Then when we go to the ordinal scale of measurement, we have a meaningful order among the categories, but remember that the numbers there just represented a position inside the distribution, but those numbers had not numerical meaning or mathematical meaning. And then we can go to the simplest type of data you can have in your study, which is nominal data or nominal variables. And here you can have different categories, but the order is not important among those categories. So if you see, you can always go down in this scale, and you can, for example, categorize a continuous variable. But when you do that, you will always be losing information. So let's think about this with an example. For example, you want to perform a study in which you will test an intervention which aims to reduce weight among obese people. So we could measure its efficacy using the change in the body mass index of the patients. We would be using body mass index as a continuous variable, and we would be able to assess how much weight the patients lost in each group and see if that difference is statistically significant or not. But we could also choose to categorize that variable, body mass index, using cutoff points and create different categories such as obese, those with a body mass index over 30, or the category of overweight people or healthy weight people, and so on. So in this way, we could assess the percentage of patients that changed categories for each of the groups, placebo or the intervention. And for example, the percentage of patients that went from obese to healthy weight in each group, and so on. The choice will always depend on what we want to show. Sometimes, by categorizing the variables, we gain clinical relevance. But every time we go down in the measurement scale, we lose information. So this decision must be carefully made. For example, if we just created the categories inside the body mass index, we can have many patients that decrease, for example, 10 kilograms or more, but could, even when they lost all those pounds or kilograms, they can still be inside the obese category, and maybe we don't see a difference just because we were not managing continuous data. So thanks for your attention, and I hope this video was helpful.